Look up at the sky. You can see clouds, you can see sunlight, you can feel the wind, but you can't actually see the thing making all of this possible. The air around you. Earth is surrounded by a huge blanket of gases called the atmosphere. It is held close to Earth by gravity. And although it looks invisible and almost weightless, this atmosphere is doing some serious work. It provides gases essential for life. It shields Earth from harmful radiation from the sun, including ultraviolet radiation. It also traps some of the sun's energy, helping regulate Earth's temperature. And without it, there would be no clouds, no rainfall, no winds, and no weather as we know it. So the next time you look at a completely empty-looking sky, remember, it isn't empty. You're actually looking through one of the most important systems on Earth. But what exactly is this invisible blanket made of? Take a deep breath. It feels like you're breathing oxygen, but oxygen is only part of the story. About 78% of the atmosphere is nitrogen, about 21% is oxygen, and the remaining small fraction contains gases such as argon, carbon dioxide, helium, neon, krypton, xenon, ozone, and hydrogen. The atmosphere also contains water vapor and tiny dust particles. Water vapor may be present in only a small amount, generally around 0.1 to 0.4%, but it has a huge role. It helps clouds form and it helps produce precipitation. The composition of the atmosphere can also change with altitude, so the air isn't some single fixed substance, it's a mixture, and every part of that mixture has a role. But there's another interesting thing about the atmosphere. It isn't one giant layer. It's built like a 5-story building. Only, this building stretches upward for hundreds of kilometers. Imagine Earth has a gigantic building around it, 5 major floors, and each floor behaves differently. Starting from the ground, we have troposphere, stratosphere, mesosphere, thermosphere, and exosphere. These layers are identified mainly by changes in temperature and air density as we move higher. The air is densest near Earth's surface. As we climb higher, it becomes thinner and thinner. Let's start at the bottom. The troposphere is the layer where we live. It extends to roughly 12 kilometers above Earth's surface. And this is where almost all our everyday weather happens. Clouds, rain, snow, thunderstorms, wind, fog, hail, all of it. And there's an interesting pattern here. As you move higher through the troposphere, temperature generally decreases. That's why high mountain regions can be much colder than places at lower elevations. At the top is the tropopause. Above that, the atmosphere changes dramatically. Welcome to the stratosphere. It extends from above the troposphere to roughly 50 kilometers. Unlike the troposphere, the stratosphere is much more stable, with very little turbulence. That's one reason aeroplanes often fly through its lower region. But the stratosphere has something even more important: the ozone layer. Ozone is a form of oxygen made of 3 oxygen atoms, and it acts like Earth's natural sunscreen. It absorbs a large amount of the sun's harmful ultraviolet radiation. You can't see this shield, you don't feel it, but every day it helps protect living organisms on Earth's surface. Now let's keep climbing. Above the stratosphere comes the mesosphere, and this is where many visitors from space meet their fiery end. The mesosphere extends to around 80 kilometers above Earth. And it has a pretty spectacular job. It burns up many meteoroids entering Earth's atmosphere. You know those things people call shooting stars? They're not actually stars. Many are pieces of rock entering Earth's atmosphere at enormous speeds. The friction and heating make them glow brightly, and many burn up before reaching the ground, but go even higher. And we enter the thermosphere. Here the air is extremely thin, yet temperatures can rise sharply because this layer absorbs high-energy radiation from the sun. And near the Earth's poles, something incredible can happen. Charged particles carried by the solar wind interact with gases in the atmosphere. Different gases glow in different colors: green, red, purple, pink. These spectacular displays are called auroras. In the northern hemisphere, the aurora borealis. In the southern hemisphere, the aurora australis. And finally, we reach the exosphere, the outermost layer. Here the air is extremely thin. Light gases such as hydrogen and helium are present, and some of these particles can escape into space because gravity is weak. Many satellites orbit Earth in this region, and beyond it, space begins. So our atmosphere doesn't simply end at a wall. It gradually becomes thinner until Earth meets the vastness of space. Now let's come back down to Earth. Imagine you're planning to play cricket after school. You check the weather. Sunny. Perfect. Then by afternoon, dark clouds appear. The wind picks up. And suddenly, your match is cancelled. That's weather. Weather refers to the hour-to-hour and day-to-day condition of the atmosphere. It can change quickly, but climate is different. If someone says Kerala is generally warm and receives heavy rainfall, they're talking about a pattern observed over a much longer period. Climate refers to the average weather conditions and variations of a place over a long period, usually 30 years or more. Think of it this way. Your mood today is like weather. It can change quickly. Your general personality is more like climate. It takes a much longer time to change. So, weather tells us what the atmosphere is doing now. Climate tells us what pattern it usually follows over many years. But what actually controls weather? That's where the atmosphere gets busy. Weather isn't random. Several elements work together to create it. The major elements include temperature, precipitation, humidity, wind, and atmospheric pressure. Let's start with temperature. The sun provides the energy that heats Earth. But different places don't receive the same amount of solar energy. The amount of incoming solar energy received by Earth is called insolation. It generally decreases from the equator towards the poles. That's one major reason temperatures also tend to decrease from the equator towards the poles. But temperature is affected by other factors too. Altitude, distance from the sea, cloud cover, and the nature of the surface itself. That's why a desert, a mountain, and a coastal city can all experience very different temperatures even under the same sun. Now comes something you can't see, but you can definitely feel. Air pressure. Air has weight. The weight of the air pressing down on Earth's surface is called atmospheric pressure. And surprisingly, you're under the pressure of the entire atmosphere right now. So why don't you feel crushed? Because air presses on your body from all directions, while the pressure inside your body balances the pressure outside. But when pressure differs from one place to another, air starts moving, and that gives us wind. Think about standing outside on a windy day. You can't see the wind itself, but you can see what it does. Trees move, flags flutter, clouds travel across the sky. Wind is simply moving air, and air generally moves from areas of high pressure towards areas of low pressure. Warm air becomes lighter and rises, cooler air is denser and sinks. These movements create differences in pressure, and those pressure differences help drive winds. Then there's humidity. Even on a completely sunny day, the air around you contains water vapor. The amount of water vapor present in the air is called humidity. High humidity can make a hot day feel sticky and uncomfortable. But humidity isn't just about how sweaty you feel. It's essential for clouds and rainfall. Water evaporates from oceans, rivers, lakes, and plants. The water vapor rises. Higher up, the air cools. The vapor condenses into tiny droplets. Those droplets gather together to form clouds. And when enough water collects and the droplets become heavy enough, precipitation occurs, usually as rain. So temperature, pressure, wind, humidity, and precipitation aren't separate stories. They're parts of one connected system, and you can actually see one part of this system every day near the coast. Here's a simple experiment. Imagine placing two bowls outside in the sun. One contains sand, the other contains water. After a few hours, which one gets hotter? The sand. That's because land heats up faster than water. But there's another twist. After sunset, land also cools faster than water, and this simple difference creates local winds. During the day, the land becomes hotter than the sea. The air above the land heats up and rises. A low-pressure area forms over the land. Cooler air from the sea moves towards the land. This is called a sea breeze. At night, the situation reverses. The land cools faster. The sea remains comparatively warmer. Air rises over the sea. Cooler air from the land moves towards the sea. This is the land breeze. These local winds help moderate the climate of coastal regions. But India isn't just influenced by small daily breezes. Our entire country is strongly shaped by a much larger seasonal wind system, the monsoon. India has a tropical monsoon climate. The Indian Meteorological Department broadly recognizes four main seasons: winter, summer or pre-monsoon, monsoon or rainy season, and post-monsoon or retreating monsoon. Winter generally extends from December to early April. Summer or pre-monsoon runs roughly from April to June, sometimes extending into July in northwestern India. The advancing monsoon generally lasts from June to September, and the post-monsoon season runs from October to December. The Himalayan region can also experience additional seasons because of its more temperate conditions. But the monsoon is the real star of India's climate story. The word monsoon itself refers to the seasonal reversal of winds. The name comes from the Arabic word mausim, meaning season, and people have understood and observed these seasonal winds for centuries. Ancient Indian texts even describe methods used to predict rainfall. Why was rainfall prediction so important? Because agriculture depended heavily on the monsoon, and that is still true today. Now, let's see how this giant seasonal wind system actually works. Picture India in the middle of summer. The land heats up much faster than the surrounding Indian Ocean. The hot air over the land rises. This creates a large area of low pressure over the Indian subcontinent. The ocean remains comparatively cooler, with relatively higher pressure. And remember our rule, air moves from high pressure towards low pressure. So moist winds begin traveling from the surrounding oceans towards the land. These are the southwest monsoon winds. They blow towards India from the Indian Ocean, Arabian Sea and Bay of Bengal, mainly between June and September. And because these winds carry huge amounts of moisture, India receives most of its annual rainfall during this season. When the moist winds encounter mountains such as the Western Ghats and the Himalayas, the air rises. As it rises, it cools, clouds form, and heavy rainfall can follow. But after summer, the whole system begins to reverse. The Indian landmass cools faster than the surrounding seas. High pressure develops over the land. The seas remain relatively warmer, creating lower pressure. So the winds reverse. These are the northeast monsoon winds. They generally occur from October to February. Much of India receives little rainfall from them, but the southeastern coast, especially Tamil Nadu, receives significant rainfall because these winds pick up moisture from the Bay of Bengal before reaching the coast. So India's monsoon isn't simply a season when it rains a lot. It's a massive atmospheric machine powered largely by the unequal heating of land and sea and the resulting pressure differences. And when that machine becomes unusually powerful, the consequences can be enormous. In 2025, Punjab experienced severe floods. Heavy monsoon rainfall caused rivers such as the Satluj, Beas and Ravi to swell, affecting villages, farmland, houses and infrastructure. But the damage wasn't caused by rainfall alone. The floods were intensified by factors such as old or weak embankments, construction too close to rivers, accumulated silt reducing the capacity of rivers and dams, and delays or problems in communicating warnings. This is an important lesson. Natural events and human actions can sometimes combine to make a disaster much worse, and that brings us to one of the biggest atmospheric challenges today: climate change. Climate change means long-term changes in weather patterns such as temperature, rainfall, and wind. Earth's climate has changed naturally in the past, but human activities are now driving rapid changes. Burning fossil fuels, deforestation, industrial pollution. These activities increase greenhouse gases such as carbon dioxide, methane, and nitrous oxide in the atmosphere. These gases trap heat. As more heat is retained, global temperatures rise. This is global warming. And climate change can bring more frequent or intense floods and droughts. Melting glaciers, rising sea levels, heat waves, and loss of biodiversity. It can affect ecosystems, agriculture, human health, and people's livelihoods. So what can we actually do? One important idea is our carbon footprint. Your carbon footprint is the total amount of greenhouse gases released into the atmosphere as a result of your activities. Think about the electricity you use, how you travel, how much water you waste, the products you buy, and the waste you create. These choices can all contribute directly or indirectly to greenhouse gas emissions. Reducing unnecessary energy use, using renewable energy where possible, walking, cycling, or using public transport when practical, reducing waste, protecting forests, and adopting more sustainable habits can help reduce our carbon footprint. The atmosphere may be invisible, but its effects are everywhere. The air you breathe, the clouds above you, the breeze on your face, the rain outside your window, the monsoon that farmers wait for, and even the climate that shapes where and how people live. All of these are connected, so if there's one thing to remember from this entire chapter, it's this: the atmosphere isn't just the air around Earth. It is a constantly moving system that protects life, creates weather, drives the monsoon, and helps shape Earth's climate. We may not be able to see it, but we live inside it every second.